Hello and welcome to Nunley Math. I'm your host, Aaron Nunley. Thank you so much for joining us here today as we talk about multiplying and dividing integers. This is part of our series on integer and integer operations for a pre-algebra classroom. We talk about this just briefly over the course of a couple videos to refresh our students' memory on how to operate with integers, and so we can extend this into our study of rational numbers. Now, if you are already comfortable with adding and subtracting integers, you should find multiplying and dividing integers not to be too difficult, as really multiplying and dividing is really an extension of how we work with addition and subtraction. So let me let you take a look at this. Notice I have a very easy multiplication problem here, 3 times 3. Now, just like we did with learning to add integers, I want to start with an easy example and show you what this looks like on a number line. Remember that anytime we're dealing with something like 3 times 3, what we're really doing is we're doing repeated addition. In other words, if we say 3 times 3, what we're really saying is we have 3 3's that are added together. If I were to show that on a number line, I would think of it not just as 3 times 3, but I could think of it as, if I can grab my pen here, as 3 added to 3 added to 3. So on my number line, when I go to draw that, I'm going to go 3 spaces, and 3 more spaces, and 3 more spaces. 3 3's is the same as traveling 9 spaces. Remember, we always start off at 0. Now, I am aware that you guys probably have 3 times 3 equals 9 memorized from clear back probably in the 3rd grade. But the important thing for us with this example is to recognize that all we're doing is moving our arrow in the same direction multiple times. In this case, 3 times. How about 4 times negative 5? Remember, multiplication is repeated addition. So 4 times negative 5 could be thought of as 4 negative 5's being added together. And this takes a long time to write with a mouse, so please be patient with me. There you go. And if I wanted to show it on a number line, it would look like this. Negative 5, negative 5, negative 5, and negative 5, which puts me at negative 20. Notice here again that this time I've changed the numbers on the number line. I'm not counting by ones this time. I'm counting by 2, 4, 6, 8, and negative 10. Remember, multiplication is just repeated addition. Where this gets just a little bit tricky is when we have a negative times a negative, because I understand that 3 times negative 3 is 3 moves of negative 3. Let's see if I can show that here. 1, 2, 3. 3 times negative 3 would equal a negative 9. That makes sense to me. 3 moves in a negative direction. What's more difficult is for me to think about what does it mean to have negative 3 moves. Negative 3 moves. Well, here's the way I tend to look at this. If 3 moves to the negative of negative 3 is 3 moves to the left, 3 spaces, I can think of this negative sign as saying do the opposite of 3 moves of negative 3. The opposite of 3 moves of negative 3. Well, if I were to show that here, negative 3 times negative 3 is the opposite of 3 moves of negative 3. It would look like this. Negative negative 3, negative negative 3, and negative negative 3 puts me at positive 9. Now this is a little trickier. I want you to think about it again. Negative negative 3 says do the opposite of 3 moves of negative 3. If 3 moves of negative 3 is 3 moves to the left, the opposite of 3 moves of negative 3 would be 3 moves to the right. It's a little bit tricky, isn't it? Keep in mind that the opposite of moving left 3, the opposite of negative 3 would be negative negative 3 or positive 3. Let me do that one more time. Negative 6 moves of negative 2. Well, I know that 6 moves of -2 would look like this. 6 moves of -2 and would put me at -12. But if I wanted to do negative 6 moves of -2, I'm saying do the opposite of what we just did here. The opposite of what we just did here. Well, the opposite of going to the left 2 would be to go to the right 2. The opposite of moving -2 is +2. The opposite of moving -2 is +2, +2, +2, +2, and +2, ending up with me being at +12. Now, if we look at these all together, there are some patterns that might show up here, but I'm going to avoid talking about those too much right now because I'm going to come back and revisit those in just a second. We can use this same type of thinking when we're talking about division. For example, 9 divided by 3. Again, this is a fairly simple division problem. You probably could do it clear back in 3rd, maybe 4th grade, but it's important for us to see how this looks on a number line. Division is the inverse of multiplying. Division is the inverse of multiplying. So, if I have 9 split into groups of 3, instead of going 3 groups of 3 as 9, I say if I want to go from my 0, which is here, to my 9, which is here, and I want to do that in 3 equal size segments. Well, each of those segments must be 3 long. 9 divided by 3 is 3. My 9 gets split into groups of 3. Let's do another one. If I have -20 and I want to split that into groups of -5, -20 split into groups of -5 says if I'm going from 0, which is here, to -20, how many -5s would that take? Well, that's -5 there, -5 there, -5 there, and -5 there. It took 4 -5s in order to get to -20. How about this one? 9 divided into -3s. 9 divided into -3s. This one's a little bit weird. If I want to split 9 into groups of 3, I know that it's going to be 3 3s. 1, 2, 3. But how do I take a 9 and split it into -3s? That's a little harder for me to visualize. Well, I do know that a +3 is a -3. I do know that a +3 is a -3. I do know that a +3 is a -3. So if I said, take my 9 and split it into -3s, how many would it take? Well, it would take -3 of them. I've got 1, 2, 3, but I'm using the opposite on each. That's probably a little bit heady, a little bit confusing, but I think if you slow down and watch that a couple times, that should make sense. Let me do it one more time for you. I have a 12 and I want to divide it into -2s. There's 12. If I take my 12 and split it into groups of 2, it's going to be 6. But I'm not splitting this into groups of 2 slides. I want to know how many -2s does it take. Well, there's still 6 of them. 1, 2, 3, 4, 5, 6. But notice I've had to do the opposite of -2. The opposite of -2. The opposite of -2. In other words, I need the opposite of 6. The opposite of 6, -2. That's another way to think about it. If I say how many -2s do I need, if I needed 6 +2s, I would need the opposite of 6 -2s. Remember, the opposite of -2 is a +2. There again, a little bit tricky, a little bit weird, but the important thing is, if I were to take all 8 of these examples and list them on the same page, these are the exact same problems from the previous slides, I want you to notice a couple things. I had 2 examples where I had a positive and a positive. I'd have a positive times a positive and a positive divided by a positive. Notice in both cases, I just did the multiplication or division, and my answer turned out as a positive. The same thing happens when I have a negative times a negative, or a negative times a negative, or a negative divided by a negative. If I have negative divided by a negative, I get positive, positive, and positive. But look what happens when my signs are different. Positive times a negative gave me a negative. Positive divided by a negative gave me a negative. Positive divided by a negative gave me a negative. You see, most people aren't going to take the time to go through and draw a number line and think about the positives and negatives every time they do this. Instead, they're going to look for patterns like this. And they're going to say, you know what? If you have the signs that are the same, your solution is going to come out as a positive answer. Two positives multiplied or divided gives you a positive answer. Two negatives multiplied or divided gives you a negative answer, or sorry, gives you a positive answer. The only time you're going to get a negative answer with multiplication or division is if the signs are different. Now, I did have some colleagues preview my video, and they said that I really need to make one thing abundantly clear, and that is this. If I have a negative times a negative times a negative, they said it's a little unclear from our examples whether this would have a negative or a positive solution. And they thought it would be important for me to remind you that when you have a long string of multiplication and you have lots of multiplication or lots of positive and negative signs in it, it's important to remember that these rules only apply when multiplying two things together. A negative times a negative gives you a positive. And then I take that solution and I use these rules again on whatever's left over. A positive times a negative is a negative 8. Their big concern was that people might look at this and say, oh, they're all negative, therefore the solution should be positive. These two rules only apply for two integers. For two integers. If you get a long string of integers, then you've got to take that rule and apply it two at a time. Negative times a negative is a positive. That answer is positive times the negative 2 gives you a negative. Hopefully this has been helpful to you. There again, this is intended as a review of the idea of multiplying and dividing integers. It's not intended to be a full multi-day study of integers because hopefully in 7th grade math you've already seen those things before. If not, certainly leave us a tag in the comments section and say, hey, I'd like to see more about this. This is a little confusing. I'd be certainly happy to come back and revisit this with you. For now, thank you so much for joining us. Make sure you smash that like button. Make sure you leave us a comment in the comments section and make sure you ring that bell to receive notifications for every time we update Nunley Math. Wish you guys all the best of luck. Take care of yourselves. Bye-bye.